This is our second lecture on section 2.2. This is on the greatest common factor method of reducing a fraction, or putting a fraction into lowest terms, or writing an equivalent form of a fraction. So the greatest common factor method starts out with a greatest common factor, abbreviated as you see over here as GCF. So the first thing that we're going to do is we're going to find the GCF of the numerator and the denominator. So to do this with the GCF method, what we're going to do is we're going to list all the factors of the numerator and denominator. Then we're going to find the largest, the greatest, that they both have in common. Hence the name, greatest common factor. Once we've done that, then we factor the numerator and the denominator using the GCF. In other words, we create a multiplication problem of that GCF that we found times another factor, which gives us our original number. And then we're going to cancel that, which means divide it out, of both the numerator and the denominator. We're going to come across the fundamental theorem of fractions in just a little bit here, and you'll see how this applies, because that is what we're using to divide that out. So step 4, we're going to rewrite the fraction and we're going to cancel it. So here you've seen me do 2/24. So let's go ahead and scroll this up so we focus our attention right on here. So 12/24, we're going to put it into its lowest terms. So the first step is we're going to factor each of the numbers, 12 and 24. So 1 times 12, 2 times 6, and 3 times 4. Now I call this my method of meeting in the middle, and the way I do it is I start out with the smallest number times what gives me 12. So always start with 1. 1 times the number itself gives you 12. Then does 2 go into it? Yes. 2 times 6 is 12. Does 3 go into it? Yes. 3 times 4 is 12. These two numbers are right next to each other. You've met yourself in the middle. You know you have all the factors. So looking at 24 in the same way, 1 times 24. 2, does 2 go into it? Yes. 2 times 12. Does 3 go into it? Yes. 3 times 8. And then 4, does 4 go into it? Yes. 4 times 6. Does 5 go into it? No. You've met yourself in the middle, you know you're done. Then you take a look at each of these factorizations, all the factors of these numbers, and you're going to see that 12 is the greatest one in common. And I start up from the largest side and start comparing to see where we see a common one. So my GCF is equal to 12. Now I'm going to rewrite 12 and 24 as products using 12. So 12 is 12 times 1. And then 24 is 12 times 2. And you can go back up to your work here to find that. So there we go. Now we would cancel the 12, and we're left with 1/2. And so we rewrite it as 1/2. So we're going to reduce 42/45 in this manner. So 42, we start out here with 1 and 42. And then we say, does 2 go into it? Yes, 2 times 21. And then does 3 go into it? Yes, 3 goes into it. 3 times 1 and 4, so 14. I'm doing that division in my head. 4 go into it? No. 5 go into it? No. 6 goes into it? Yes, 6 times 7. And we've met ourselves in the middle, and so we know we're done. So we now have all the factors of 42. Now we're going to do the same thing with 45. 1 and 45. And then does 2 go into it? No, it's odd. 3, yes, 3 times 15 goes into it. And then 4, no. 5, yes, 5 times 9. 6, no. 7, no. 8, no. We have all the factors. So now we can find the GCF, and we're going to do that by looking from the highest end to the smallest end. So we go through here, and we see that 3 is our largest one, so our GCF is 3. And then we're going to rewrite these. So 42 is 3 times 14. And then we have 45 as 3 times 15. And now we can cancel the 3's, and we have our lowest terms as 14/15. And that'll be our final answer. And that's the lowest terms, or reduced fraction. This is equivalent to 42/45.